Welcome to my YouTube channel. In the previous video I was caught up on doing thorium 90, which is a actinide, and I intend to continue with thorium and also do real fast a bunch of other elements so that you could get enough exercise and enough doing of this electronic configuration. Let's go back to thorium without any waste of time. That's period 7, so it's a 5. For lanthanides and actinides, it's not P as for main elements, it's not P minus 1. As for D, it's P minus 2. So 7 means P minus 2, 5F. And let's see what group it is. Okay, you could see that it's F1. 5F1 is where I stop. Now, from 89, if I go back to my previous Nobel Gas, 89 here, 89, 88, 87, all the way to 86 is 6P6. That's radon. Radon, 6P6. with 86 electrons. Okay, so I'm going to go write down radon and then start from after 6p6 to 7s5f. 7s5f. 5f1 is where I stop because that's my stop sign, and because it's an actinide, I'm going to continue one more sub level to 60 and put 51. Okay, let's just get rid of this. We have to mix with our, and then 2 maximum capacity for this, and 86 electrons plus the 4 electron here should make to the 90. That is thorium. Okay, so again, the period for a lanthanide and actinide is P pi minus 2, and for a transition metal is P minus 1. For a normal main group elements, it's just P. Let's move on to yet another example, and I'm going to do miscellaneous examples on and on so that you get the good comment on doing electronic configurations. Okay, chromium 24. Chromium is a transition metal. It's the same gridlock trick here for chromium. That's chromium there, group D4 and period 4. So if it's period, that's chromium. Period 4, I do P minus 1, so it's 3D, and that's D4. That's where I do actually stop the D4, and I then go back from 24 all the way to 19, no transition metal, and then to 18. Argon is 3p6. At 3p6 and with 18 electrons, if you notice, that's argon. So Krypton is going to be argon, and I start after 3p6 to do a 4s and a 3d. 3d is my stop sign, so I do 4s to 3d4. There was an exception about this, that we don't accept this and we just write down Krypton 24, my bad, not Krypton, chromium 24, argon 4s1, 3d5. That was for D transition metals. D4 and D9 are going to borrow one from the S layer to make a D5 or a D10, which is more stable. If you now look, 18 plus the 6 is going to give you the 24 that you're looking for. Let's do yet another example. That would be antimony. The sign for antimony is Sp. Sp. As you look, it's 51. So I do the gridlock for antimony. It's a main element. That's the group 5 and period 4, as you could see. That's antimony. Period 4 means 4, and group 5 means just P1, P2, P3. So 4, P3 is where I stop. Antimony has got 50. Oh, my bad. It's period 5. I don't know why I did arsenic. Antimony is 51 Sp. Okay, so that's group 5 to the P and then period 5. So P3 for group 5 and group period 5 for just P because it's a main element. Let me just count down to the previous Nobel gas. That's antimony with 51 electron. If I move all the way to 37, no Nobel gas, and 36 is this 4p6 Krypton. 4p6 Krypton with 36 electrons. Okay, so I do Krypton here. and I start after 4p6, it's a 5s and then a 4d and a 5p. 5s, 4d, 5p. A 5p3 is where I shall stop. Let's just get rid of this. And then S2d10, maximum capacity. Okay, so with these 15 electrons and Krypton's own 36, it's going to make 251, and that's the configuration for your antimony. The next one that I'm going to do is copper 29. Let's go to 29 copper, and copper is here, Cu. I wish you could see that. Let me just use my grid log one more time. Cu period 4 and group D9. That's a transition metal. So period 4 means 4 minus 1. So it's 3D and a D9. Okay, so there's also a trick after that. When I complete, I have to borrow 1 electron from my S layer as well. So this is copper 29. If I go back all the way to 19, there's no noble gas. Argon is the 3p6 with 18 electrons. So 3p6, 18 electrons, argon. That's where I want to stop. Okay, so my bad, start. I start after 3p6 right here with doing, so let's do argon first and then start after 3p6, 4s, 3d, 3d9 is where I stop. So there's the 4s, and I then borrow 1 electron from the S layer to make it, instead of S2d9, S1d10. That's the configuration. And if you look, 29, oh my bad, 18 plus 11 is your 29 that you're looking for. Okay, so that's the configuration of copper. Let's do yet another example, and that's the example of, let's see if I could get these beakers not to pour down and make me mad. Bismuth 83 is my other example. So for bismuth 83, bismuth is also a main element, and I'm gonna go do my grid lock for bismuth. That is right here, 83. So I put here my period, that's period 6, and it's group 5. So bismuth is group 5, is a P3, and period 6, so I do 6p3. That's where I have to stop. Now let's work out the way I have to start, and that's bismuth with 83 electrons. As I go back all the way to cesium, you could see there's no noble gas, and as I move on to 1 more electron, cesium is 55. I will go down 1 more electron. That's the 54 electron of xenon with a configuration of 5p6, because xenon is period 5. Okay, 5p6. That's where I start, just after, right after 5p6. So that's a xenon, and then 5, and then 6s, 4f, 5d, 6p. So 6s, 4f, 5d, 6p. 6p3 is where I stop, a d10, an f14, and an s2. Okay, so this makes 24 plus the 5 plus the 54. This number 8 and 5, 13 actually makes that 83. That's the configuration for your bismuth. Next is the configuration of chlorine that I'm looking after it, and chlorine is just 17 electrons. Okay, so let's just go on to chlorine 17 and do that real quick. Sorry, it's getting me a little bit nervous how this thing's goes. Let's put this on the top a little bit. I hope you could see this clearly now. I think you could. Yeah. Let's continue with this chlorine. Now chlorine, I'm going to put my grid lock one more time on chlorine. Chlorine is right here in group 7. So that's the column. And this is the period. That's chlorine with 17 electrons. It's a main element, group 7, so that's a P5. And also period 3, so 3p5. Okay, and if you look at chlorine with 17 electrons, you have to go back all the way from 17 electrons to 11, and there is no noble gas that you meet. As soon as you move from 11 to 10, that's neon with 2p6 configuration. So 2p6 neon 10 electrons is where you have to start. My bad. So that's neon, and then after 2p6 I have a 3s and a 3p. So 3s, 3p5 is where I stop, and s has maximum of 2. So it's 10 plus 7, 10 for neon and 7 there to make a 17. That's chlorine 17. The next one that I want to address is radon 88. Radon 88, and I want to do that. Radon is a main group element, okay, and it's right here in group 2. Okay, that's group 2 and period 6. So because my bad, period 7 radon. Let's have radon in our gridlock. Okay, yes we do. So radon is period 7. It's 7s2. S2 is the configuration for any zinc group 2. Okay, and as we go back from radon 88 to 87, there's nothing back to the 86. That's the 6p6 configuration of radon with 86 electrons. Okay, that's the 3 information I need from there. Then I continue from radon for my bad if I told I'm gonna go radon here. This is radium. Okay, my bad for if I just told radon to this. Radon is a noble gas. Radium is group 2. So we have group 2 with down 3 strontium, barium, radium. I apologize if I said radon a couple times before I realized this is radium, not radon. So the radium is radon, and then I continue from 6p6, 7s, 5f, 6d. Let's see. If I do 7s and I put 2, that's it. Okay, and it has 66 in radon plus the 2 makes 88. That's radon. Okay, so that's radon. The next one that I want to do is indium 49. Okay, let's do indium 49. IN49. Indium is also a main group element, so I have to do my gridlock job again to find out about that. Indium, it's right here, 49. You can see this green box here. It's period 5 and it's group 3. So group 3 means a P1, and period 5 from main elements means just a 5. So it's a 5p1 that we have to stop. And then indium 49 right here. If I go back all the way to 37, there's no noble gas, and as soon as I move to Krypton, it's the 4p6 configuration of Krypton with 36 electrons. Okay, so I move on to Krypton and my table here. 4p6 is right here, and then I continue with 5s, 4d, 5p. 5s, 4d, 5p1 as my stop sign, so that's where I stop. And I put 10 electrons here, 2 electrons here, and it's 13 with the 36. That makes exactly 49. That's the configuration for indium 49. Let's do next example, which is nickel 28, Ni28. Nickel is here. Let me do my gridlock here. It's period 4 because it's a transition metal. I have to do 4 minus 1, p minus 1, that's for d transition metal. So instead of 4, I do 3, and it's a d8, as you can see, for nickel. 3d8. Okay, and then I continue. That is my stop sign. Then I continue from nickel 28 all the way to potassium with 19 electrons, and as I move to 18, that's argon with the 3p6 configuration, and that's where I have to start after it. So I do argon, and then I start until I hit 3d8. Okay, that's the 3p6 4s 3d 4s 3d8. Let's get rid of this. Okay, hopefully, and the maximum capacity for S here, that makes 18 plus the 10, and that's make 28. Remember, if you have a D4 or D9, you have to borrow one, because D4 and D9 are exceptions. Let's do uranium 92. Uranium 92. Uranium is an actinide, I believe. Let's go to our periodic table, do the grid job on it. So that's the periodic table, and there's the uranium with 92 electrons. It's a period 7, as you could see, and it's an F3. Okay, so F3 is where I stop, and it's going to be P minus 2, so 5F3. Uranium has 92 electrons, so if I just put this back and look at here with my uranium with 92 electrons, it goes to 89. 89 is right here, back to 88, 87. As soon as you hit this radon here, 86, that's a noble gas, so 6p6 with 86 electron of radon, and you do radon, and you continue after 6p6 until you hit 5f3, and there you continue, because it's an actinium, to do d level and add 1 electron to that d level as well. That's the only difference from transition metals or main elements that you do with actinide or lanthanide. You actually continue after F and fill out 1 more electron in the next d electron sub level, and I explained why you do that. So let's start after 6p6. 6p 7s 4f 5f. So 7s 5f 3, and you do go on to 6d to put 1 electron in your d level. That's that, and s2. So there's 6 electrons there. Radon has 86 itself. That makes the 92 that you're looking for. That's the configuration for your uranium 92, and then you go to gallium 31. Let's see how much time I have. Good. Gallium 31. So this time, hopefully, last time I was like cut off in the middle of doing a video. It was I think minute 28 that I was run out of time. It was like I couldn't finish thorium, but this time I managed to do it, hopefully, because I have 1 more to do after this. So gallium 31, gallium is right here, and I'm going to use it's a main element. I'm going to use my grid lock to do the period and the group and the period. It's group 3 and period 4. So I do 4p, group 3 means p1, so that's, oops, I apologize for that. So gallium is the 31 electrons, okay, 4p1. I now use the strategy to go back, hunt for the previous noble gas. 31 electrons all the way to 19, you meet no noble gas. As soon as you move to 18, there's the argon, and argon has 18 electrons with 3p6 configuration. Argon 3p6 with 18 electrons. Okay, so argon, and then you move after the 3p6 here to stop at 4p. 3p6, 4s, 3d, 4p. So 4s, 3d, 4p. It's 4p1. Let's just get rid of this one on the top. Not intermingle. and then 10 here, 2 here. Maximum capacities, yeah? Maximum capacity for D is 10 and for S is 2, so that's 13 electrons plus the 18 that we previously has, and that gives you 31 electrons. The last example that I want to wrap up here is S13 85. So AT, that's a halogen that you seldom hear of, but it's a Nobel. It's a halogen, but you should be able to actually do the electronic configuration. You just don't see much about chemistry of astatine because astatine is just radioactive. Okay, astatine is here right below iodine, and it's group 7. Okay, so let's do astatine here with 85 electrons. It's group 7, so it's P5, and it's period 6 main elements, so 6 remains a 6, and 6p5 is going to be our stop sign. Let's go back from the 85 electrons in astatine to all the way to meet the first noble gas. All the way, if you go to 55, you meet no noble gas. As soon as you go to 54, you meet xenon with a 5p6 configuration and 54 electrons. Okay, so I move back to my S18 here with xenon, and then I move from 5p6 to 6s 4f 5d 6p 6s 4f 5d 6p5. That's my stop sign. Let's just also get rid of this if I could not spill one of the small beakers, and it makes me mad and makes my table a mess. 10 electrons, 14 electrons, 2 electrons here. And if you do 54 plus that 24 and that 7, let's see, this is 8 and 7, 5, but it's going to be my 85 electrons. So that's astatine. I hope you should be able to do any element in the periodic table, literally any element, okay? The only thing is that you make the distinction between 3 groups or categories of elements. That's the first, that's the main elements that has S2 and S1, S2, and P1 all the way to P6 configurations. D transition metals that have D1 to D10, and you have to count, and F the actinides and mantines, and you have to do F1 all the way to F14. For main elements, the period just gave you the number preceding that sublevel. For D transition metals, if it's a period 4, then you do, if it's a period 6, then you do 6 minus 1, so you get 5D. And for F theories, if it's a group 6, you do a 4F, and it's if the group 7, if it's a period 6, you do a 4F, and it says a period 5, you do 5 minus 2, a 7 minus 2, a 5F. So that's the whole thing. Let's just wrap it up here for this video.